The following recording is the beta version of a program being developed by the Education Broadcasting Network, EBN, for the Ministry of Education in Jamaica. It contains valid materials generated by the grade-level national curriculum, which children will find helpful in their pursuit of knowledge. In order to best shape the final product, you are invited to send questions and concerns to feedback@moeschools.edu.jm.
Hello again, GSAT students. This is your revision time, a program put together by the Ministry of Education just for you. I am Karen Goburn, your guide for today. Before we get into our revision session, we need to take a break. We'll be right back. Welcome back. We're here in studio with Raquel Ranger Cowan, our math specialist for this session. Welcome, Raquel.
Thank you.
Our first question comes to us from a student in Clarendon, and it asks, when is it important to put a 0 in the answer when one divides numbers like 612 divided by 6?
Now, students, we're going to be illustrating with some base 10 pieces. So the example that was read, 612 divided by 6, will be represented with, and I have here what represents 100, what represents 10, and what represents units or ones. So 612 is represented by 6 of the hundreds, 1 of the tens, and 2 of the units. Now, students, what you need to understand is that division can either be the fair share model or the partition model. We're going to be illustrating using the fair share model. So, our 612 will be shared equally among 6 groups. Now let us look at our 600 first. I have 600s, and I can share it equally among 6, with each person getting 100. Let us illustrate. 1, 2, 3, 4, 5, and 6, which means when 600 is divided equally into 6 groups, each group will have 100. Now let us look at our 110. 110 as is cannot be equally divided among 6 groups. So what we're going to be doing is trading 1 of the tens for 10 units. So our 110 was traded for 10 units, and now we have a total of 12 units. Now we are going to be sharing our 12 units equally into 6 groups. So we will put 1 here, 1 there, 1 here, 1 here, 1 here, and another one there. But we still have some more, so let us continue sharing. Another one there, 1 here, 1 here, 1 here, 1 here, and 1 there. Therefore, when 612 is equally divided into 6 groups, each group will get 102. Now let us illustrate with the working out. We have our 612 to be equally divided by 6. When 600 is equally divided into 6 groups, each group gets 100, which means we would have used a total of 600 with a remainder of 12. We show our remainder of 12 by subtracting 600 from 612. Now we have 110 and 2 units. As was illustrated, no group could get a set of 10 and hence we traded. To show that no group gets a set of 10, we indicate with the 0. Having traded, we shared 12 units equally among 6 groups. Therefore, each group would get 2 units. And we show that there are a total of 12 units shared. 12 from 12 leaves 0.
Our next question coming in from a student living in St. Anne. What determines whether we round up or down when given a problem like, what is 5 2/3 rounded to the nearest whole number?
Now students, what you need to remember is that rounding off is giving an approximate value. The number in question, 5 2/3, let me just write that, is the number that is required to be rounded off to the nearest whole number. We have here a part or portion of a number line. Students, we need to remember that before 5, we have other whole numbers beginning with 0. For example, 0, 1, 2, 3, and 4. And after 6, we have other whole numbers such as 7, 8, 9, and so on. Let us look at the space between 5 and 6. We need to indicate where 2/3 will lie. We will divide the space between 5 and 6 into 3 equal parts. We have divided the space between 5 and 6 into 3 equal parts. Therefore, this is a third of that space, this is another third, and this is also another third. Which means 5 1/3 would lie here, 5 2/3 would lie about there. Our number in question is 5 2/3. Now, when we look at where 5 2/3 lie in relation to the whole numbers 5 and 6, we realize that 5 2/3 is closer to the 6. Therefore, when 5 2/3 is rounded to the nearest whole number, our answer is 6. So remember students, if the fractional part of the number which is in question is a half or more, we round up to the next whole number. If it is less than a half, then we round down to a whole number.
Thank you, Raquel. Another question from St. Catherine this time. And the student is asking, what is the reason for finding the LCM of the denominators when adding or subtracting unlike fractions? For example, 1/3 plus 1/5.
Okay, students, when adding unlike fractions, what is important is that we rename the fractions so that they become like fractions. I'll illustrate with the example that was read. A third plus a fifth. Now, using the same sized holes to illustrate each of the fractions, I will illustrate a third with this diagram. Here we have the entire diagram equally divided into 3 parts. A third is one of the 3 equal parts highlighted. Over here, we have this diagram equally divided into 5 parts. A fifth would be one of the 5 parts shaded. Now, our fractions shown are of different fractional parts. What is key is that we need to get both pieces the same fractional parts. Now, on this diagram, we can see our thirds, and what I've actually done is to also place the fifths. Over here, we can see the fifths, and I've also placed my thirds. Now, on this diagram, I will shade my 1/3. However, my 1/3, as we had it there, is now represented by 5/15. Now, on this diagram, where I shaded the 1/3, you would have noticed that my entire diagram is now divided into 15 equal parts. Therefore, 1/3 is renamed as 5/15. On this diagram, I will shade my 1/5. And likewise, my 1/5 is now renamed to 3/15. Therefore, we now have 2 fractions which are of like denominators. A third renamed to 5/15 and a fifth renamed to 3/15. 5/15 plus 3/15 give 8/15. So let us quickly go through why we find LCM. Taking the example, a third plus a fifth, we realize that these are of different fractional parts. So remember, students, that in order to add fractions which are of unlike denominators, for example, a third and a fifth, we must rename each so that they become like fractions. One of the ways to do this is to find the LCM of the denominators. In this case, our denominators are 3 and 5. Therefore, our LCM will be 15. We will then rename a third to 15ths. A third is equivalent to 5/15. A fifth is equivalent to 3/15. Now we have like fractions as indicated on the diagram, so we can go ahead and add 5/15 plus 3/15 equal 8/15.
A student from St. Mary is posing this question. How do we multiply two proper fractions? For example, a quarter multiplied by 2/3.
Okay, students, I have that question written here. A quarter multiplied by 2/3. Now, it is very important that we understand the interpretation of this problem. It actually means, what is a quarter of 2/3 or 2/3 of a quarter, depending on the context in which it is placed. This time, however, we're going to be using a quarter of 2/3. Now, if you look at the diagram here, I have my whole divided into 3 equal parts. A third, another third, and another third. I am going to highlight 2/3. Now that we have our 2/3 shaded, what I'll now do is to divide my region into 4 equal parts. This I'll do in another orientation. So we divide into 2 equal parts first. Then our 4 equal parts. So we have 1, 2, 3, 4. If you notice, you will realize that our entire diagram is divided into 12 equal parts. I now need to identify a quarter of this 2/3. Remember, students, that a quarter is 1 part out of 4 equal parts. This I'll illustrate by shading this quarter. Now that we've highlighted a quarter of our region, we need to emphasize the area which overlaps or which is double shaded. If you look closely, these 2 sections have both our circular shading as well as our line shading. So when we look at the 2/3 region, a third, 2/3, a quarter of it would be this section here, which means that a quarter of 2/3 is equal to 2/12. Therefore, to multiply a quarter by 2/3, we multiply our numerators. 1 multiplied by 2 equals 2. Then we multiply our denominators. 4 multiplied by 3, which gives us 12. 2/12. So students, remember that 2/12 can be simplified. To do this, we divide our numerator and our denominator by a common factor, which is 2. Therefore, 2 divided by 2 gives us 1, and 12 divided by 2 gives us 6. So remember that 2/12 is the same as 1/6.
Thank you for watching, students. We need to take a break and we'll be right back. Welcome back. With us in-house is our math specialist, Tajna Price, for this segment of the math session. Welcome, Ms. Price.
Thank you.
And we're continuing with a question that comes in from Portland. This student wants to know, why are we often told to multiply the divisor and the dividend by the same power of 10, then just divide when we divide decimals?
Students, we are often told to multiply the divisor and the dividend by a power of 10 because of the decimal system that is used. Now, the decimal system is based on 10 make 1. It simply means if we multiply both the divisor and the dividend by the same power of 10, the value of the numbers would remain the same. Using the question, 2.4 divided by 0.6 means how many 6/10 are in 2 4/10. We're going to illustrate this using our base 10 pieces. Using the flat to represent a whole, 2 4/10 would mean that we have 2 flats, and using our longs to represent a tenth, 4/10 would mean we have 4 longs. Now what we're going to be doing is to see how many of the 6/10 can we get from the 2 4/10. We are going to trade one of our unit for tenths. Now each unit contains 10 tenths. One, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We will now trade our next unit for 10 tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So here we have 24 tenths. We're now going to see how many 6/10 are in 24 tenths. Now remember that each of these represents a tenth. In order to get 6/10, we would need 6 of these. 1, 2, 3, 4, 5, 6. So here we have one group of 6/10. 1, 2, 3, 4, 5, 6. Another group of 6/10. 1, 2, 3, 4, 5, 6. That's another group of 6/10. And 1, 2, 3, 4, 5, 6. Another group of 6/10. What this means is that we have 1, 2, 3, 4 groups of 6/10. Therefore, 2.4 divided by 0.6 or 2 4/10 divided by 6/10 equal 4. So where we have 2.4 divided by 0.6, what we always try to do is to get the divisor to be a whole number. In order to do that, we multiply by a power of 10. In this case, the divisor is 6/10. So to get it to a whole number, we can multiply both the numerator and the denominator by 10. This will result in 24 divided by 6. Therefore, 24 divided by 6 equals 4. So students, remember when we traded, we had 24/10, and now we're dividing it by 6/10, which means how many 6/10 can we get from 24/10? And the answer would be 4.
Our next question comes to us from a student in Kingston this time. And it says, what relationship exists among fractions, decimals, and percentages?
When we write a number as a fraction, as a decimal, or as a percentage, then all we are doing is expressing the number in different ways. Say, for example, we have 0.85 to be expressed as a fraction or as a percentage. What we would do, we would start with the whole, and in order to express a number as a percentage, it means that the whole is divided into 100 equal parts. As the word suggests, percentage means out of 100. So here, we have divided the whole into 100 equal pieces. 0.85, which is the same thing as 85/100th, or 8/10 and 5/100th. Now let me represent it on my 100th grid. I am going to shade 8/10. 1, 2, 3, 4, 5, 6, 7, and 8. Now I'm going to shade my 5/100ths. 1, 2, 3, 4, and 5. What this means is 0.85 can be written as 85/100th which is the same thing as 85%. Therefore, 0.85, which is 85/100th, can be simplified by dividing the numerator and the denominator by a common factor, in this case 5. Therefore, 0.85 or 85/100th will give us 17/20.
Our final question, coming from a student in St. Elizabeth, asks, the circumference of a wheel is 110 centimeters. How do I find its diameter?
In order to address this question, we have to know the relationship between the circumference of a circle and its diameter. This string represents the diameter of the circle. I'm going to use this string to represent the circumference of the circle. Let's compare the length of the diameter with the length of the circumference. One, two, three, and a fraction. This means that the diameter can be taken from the circumference approximately 3 times and a fraction. That fraction is approximately 1/7. This means that the circumference of a circle is 3 1/7 of its diameter. Let me now write this in a statement. The circumference equals the diameter multiplied by 3 1/7. 3 1/7, the same thing as 22/7, is what we refer to in mathematics as pi. In order to get the circumference, we multiplied pi by the diameter. Therefore, to get the diameter, we need to divide the circumference by pi. The wheel has a circumference of 110 centimeters. We divide by pi, which is 22/7, to get a diameter of 35 centimeters.
We would like to thank Tajna and Raquel for being with us in this session. We would also like to thank our viewers for staying with us. Continue watching for more in our revision programs. Remember also to keep practicing your study tips. Again, thanks for staying with us. Good day.